Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you. Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up. And check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
Go above and beyond.
they become very good at what they do, but only
0.1%.
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
With Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on Current Initiatives. And now, to our guest. Hello, this is Richard Jacobs with the Finding Genius podcast. My guest today is Marco Castellano. He's a researcher at INAF, the Osservatorio Astronomico di Roma. I hope I said that right.
Yes.
So we're going to talk about the James Webb Telescope and his work. So Marco, thank you for coming.
Thank you for inviting me.
So tell me, what is your work like right now, and how are you involved with the James Webb Telescope?
Well, I am a researcher investigating galaxy formation and galaxy evolution, and in particular, my research field is looking at the very first galaxies. So the galaxies that formed, the very first galaxies that formed after the Big Bang. Just to give a context, the universe is now 7.7 billion years old, and we are looking for galaxies that formed a few hundred million years after the Big Bang. And James Webb Space Telescope is the instrument that will give a revolution in this field thanks to its sensitivity in the near infrared and its resolving power. So I did this research with the other instrument, the Hubble Space Telescope, ground-based giant telescopes, but James Webb is really a revolution because it's opening a completely new window into this very distant epoch of the universe. And first results came this summer, and they are already very, very interesting. As you know, there's been a lot of discussion about these very first images, and James Webb is really incredible in this respect.
When were the first galaxies able to be formed, and why did it take hundreds of millions of years from the start of the Big Bang?
Well, so after the Big Bang, the hydrogen and helium that formed with the so-called primordial nucleosynthesis were at the beginning very, very hot. And then through the expansion of the universe, they recombined, formed atoms, but it took some time before the potential wells, apparently due to dark matter, allowed the gas to cool to the point where it could form the very first objects and the very first stars. We haven't yet reached those very first stars. They likely formed about 100 million years after the Big Bang, but we haven't detected them yet. These observations, however, allowed us to push the frontier, because this is really the frontier of the cosmology, of observational astronomy. So we could investigate the first billion years of galaxy formation, Hubble Space Telescope, so objects about 500 million years and 1 billion years after the Big Bang. But suddenly, with the first James Webb observations, this frontier was pushed to objects about 200 to 300 million years after the Big Bang. It's very important to constrain, to investigate this epoch of galaxy formation, because very little is known of it. There are theoretical predictions, but we know that the very first stars and the very first supermassive black holes formed during that epoch. So we need James Webb to try detecting these very first objects, including the first stars that only had the hydrogen and helium that formed during primordial nucleosynthesis, while all the stars we have detected so far all have heavier elements that formed inside stars themselves.
Yeah, I heard that. I heard that stars need to go through several life cycles in order to produce heavier elements. Is that true?
Yes. Well, everything is produced within stars thanks to nuclear fusion, but the very first stars only had hydrogen and helium, and that's really the ultimate goal for for researchers in my field, to find these very first stars. We don't know how they look like. They probably were very, very massive and very hot. This is the theoretical scenario, but we are all looking for that. That's the beginning, and what's fascinating too is that that's the beginning of let's say life in the universe, life in the sense that the beginning of light in the universe, but also to some extent the beginning of life, because starting with those stars, all elements could form, including those that make up our planet and ourselves.
Well, why would stars today have heavier elements in them? Was it just older stars that kept burning, making heavier elements? or were they formed differently?
No, just because starting from those very first stars, the nuclear fusion within them started to form carbon and all the elements heavier than helium, and dispersing them into space within galaxies and even outside galaxies. So the other generations of stars that formed afterwards included all those elements and richer and richer abundance of heavier elements. So the sun now is mostly hydrogen and helium, but still has some percent of elements heavier than helium. But the very first stars had no other elements at all, and the generations of stars that formed just after the first generation had a very small amount of these elements. So the universe has been progressively enriched with elements heavier than helium, while hydrogen and helium formed during the initial phase after the Big Bang. So that's why how stars form all the atoms out of nuclear burning of hydrogen and helium.
And the James Webb supposedly has been able to see some early galaxies. From the pictures, can you learn anything new about old galaxies and their formation?
Yeah, well, the first results are quite surprising. Of course, we have to be to investigate further, because these are the very first results from a new instrument. We are still learning how to use this wonderful instrument, but apparently there seems to be more star formation in this very early phase of the life of the universe than we initially thought. So many works, including mine, has found a surprisingly high number of galaxies and of bright galaxies in these first 400 million years after the Big Bang, while very few were expected. We definitely need to investigate further, because there are a lot of subtleties in this kind of investigation of work. But the first results bit of a surprise with the number and brightness of these first galaxies. So that was quite unexpected and quite surprising, and it seems that galaxies were more efficient at forming stars at those early epochs, more efficient than theoretical models predicted and other observations seemed to predict before these JWST observations.
So what is the consequence of this, that they're more efficient than you thought? If you go backwards in time, does that mean that galaxies could have appeared earlier than they did?
Possibly, or possibly there's some role in how this first generation of stars formed. Maybe the cooling of gas inside the dark matter halos was more efficient. Star formation was more efficient. Possibly a lack of say negative feedback effect, because galaxies kind of regulate their star formation process. Stars form in gas clouds, but there are also effects that prevent the formation of stars, like ionizing output from other stars, or the effect from winds from the massive black holes. So there is a lot of physics that regulates star formation, and it can be that those early epochs star formation was more efficient than current models allow. So we need to understand the physics of this very early star formation. Of course, I'm extrapolating from these early results, there is still a lot to learn, but this is a possibility, and it's very, very interesting, and we need to investigate these observations.
So, what is theoretically the least amount of time since the Big Bang where a galaxy could form, and what is that process like? How does a galaxy form initially, and how does a star form?
Well, they form because there are these potential wells where basically gas falls and settles into a disk and cools, emitting radiation while it falls. And when it's cold enough, it's gravitationally bound, and stars can form. There is a variety of predictions on when and how these very first stars could form. It's likely around 100 million years after the Big Bang, possibly a bit later or a bit earlier, but that's good guess. It's their epoch, because we need enough time for this process to happen, so gas cooling to the point that stars gravity make the gas fall to the point of forming the very first star clusters. And these are indeed the very first stars I mentioned at the beginning, that we still have to find, that were likely hot and massive, but again, this is really unknown because we haven't reached their epoch with the available observations, so a lot of uncertainties on these. And one other aspect is the formation of the black holes, because we know that 1 billion years after the Big Bang, and even a bit earlier, there were already very, very massive black holes, galaxies with inside them a black hole billions of times the mass of the sun, and very, very little is known about how these giant black holes could form, possibly out of the collapse of these first stars, or from the collapse of giant gas clouds, but very little is known. So I'm really speaking about something that for which we have variety of predictions, of scenarios, but very little observations. This JWST has just started to go in that direction, with the very first observation that were really pushing a lot more than HST could do, but we haven't reached yet the, let's say, final frontier of the very first stars.
Well, since James Webb is in infrared, can you combine the same image with Hubble and what it would see to get more information? Can you do that?
Yeah, sure, we do. Hubble gives us the visible light, the UV and visible light, up to infrared around 1 micron, 1.5 micron wavelength, while Hubble starts more or less where HST ends, so around 1 micron down to 20 microns. So observations, now many observations have been designed so to exploit previous observations available with HST, or HST observation can be asked to support. This is very important because to investigate all objects in the sky, you need multi-wavelength information, constrain their physical properties, and starting with their distance from us, their redshift. To do this, you need as many wavelengths as possible. So usually telescopes acquire images with a filter that selects some wavelengths, and with HST you sample the UV to visible near infrared, and with JWST from the near to the mid infrared, so that gives you a very long baseline to investigate galaxies and all objects in the sky.
So you said that early galaxies were more efficient at forming than you thought. What does the efficiency mean? What is formed and what is formed that is not desirable that makes it inefficient?
Efficient means that you can convert more gas into stars. As I said, in the galaxies, in our galaxies and in galaxies nearby, you see that there are many contrasting effects that can also prevent star formation, like a negative feedback from the black holes or from other stars. So if you convert some percent of the gas into stars, because the various processes regulate star formation, say a kind of loop. Possibly first galaxies, if this result is confirmed, possibly they had higher star formation, but again, theoretical models didn't predict this, and we don't know yet how this could be. If that's something related to the feedback from the first star clusters, if it was different, if it was inefficient, or if the gas cooling was more efficient, we don't know yet.
What images from the James Webb Telescope are showing you new things for your research?
There have been a lot of observations from the beginning. There have been some very important surveys with which James Webb started the operation, called the Early Release Science Observation. Basically, the Space Telescope Science Institute asked the researchers for programs that could help the research community understanding James Webb data and power. So there were a lot of proposals. I'm part of a few of them, and these are observations of small patches in the sky at several wavelengths, mostly focused on, of course I'm speaking of the surveys in which I'm involved, focused on galaxy evolution and the very first galaxies. But there have been a lot of surveys of this kind also for other research topics. But the paper I've published comes from a wonderful collaboration called GLASS, led by Professor Treu at UCLA, with tens of researchers all around the world analyzing these early release science observations of a field to investigate galaxy evolution and the very first galaxies. But there are several important ongoing programs that will give a lot of information on galaxy evolution in the coming year. So I expect that the coming year will be very, very important research field with the data that have been acquired or are being acquired.
Do you know what the images are that the James Webb Telescope will look at in the future? Is there a schedule of what's planned, or is it change all the time?
No, there is a very tight schedule indeed, because the way these observatories work is that call for proposal are issued once per year, so all researchers submit their proposals for observation. So for the coming year, even year and a half, if I'm not wrong, James Webb already has scheduled many programs to investigate everything from the solar system to the first galaxies. Still, they allow for additional programs like urgent programs, and you can request, but there is a schedule, and there will be new call for proposal for the upcoming cycles, as they are called, and the next call is being issued, and proposals will have to be submitted, if I'm not wrong, by the end of next January, for observations to be carried out in starting the end of next year through 2024. So it's a very efficient scheduling system, because they, of course, they want to to optimize the usage of this expensive and wonderful instrument.
What questions are you looking for the James Webb Telescope to answer for you specifically? Are there any, or is the stuff that it's going to look at not going to help you at all?
Definitely what we need now is to use the James Webb spectroscopy, because all these galaxies that I have discussed and told you about have been selected from imaging observations, so pictures at several wavelengths that allow to sample the emission at several wavelengths from the galaxies. But you can have true spectrum, because there are several instruments on board of James Webb, including spectrographs, and we need to ask James Webb to take spectra of these galaxies that we found in the images. That's because the spectrum, first of all, confirm that the galaxy is that distant, because you are never 100% sure from imaging alone, but also gives a lot of information on physical properties, because it tells you, for example, the amount of heavy elements in the stellar population inside the galaxy. It tells many ionizing photons these stellar populations emit. So they give you a lot of details of the galaxies and of their surrounding environment. So this is the next step for me, and I think for most of my colleagues, to ask for spectroscopic follow-ups of these galaxy samples.
Have you ever observed a galaxy that is different from every other galaxy out there? One that's in a class of its own, or are there no ones that are completely unique? They're just families of types of galaxies.
Yeah, there is huge variety of galaxies. Well, something that is very different from our point of view is when you look at galaxies that have been strongly lensed, because there is lensing effect due to gravitation, and sometimes you have some regions of the sky where you have a cluster of galaxies where gravity is so powerful that bends the light from other objects that are in the background. And when you look at these galaxies, you really see something different, because it's like having another telescope given to you by this lensing effect that gives a resolving power that you really cannot reach in any other way. As far as single galaxies are concerned, their variety is so huge that it's really difficult to find something that is very, very unusual. But I tell you that these first galaxies that we found, to some extent, they were surprising also, because in one case it was really, one of them really looks like disky galaxy as the ones in the nearby universe, at least at first glance, and the other one is very, very compact, so is tens of times more compact than our own galaxies, and is even more compact than the other galaxies that are so distant, and they were quite surprising, maybe not unique, but very surprising also in this respect.
Well, very good. Where's the best place for people to find out more about your work? Where can they go?
Oh, well, there are nice outreach journals. Many interesting things are reported, for example, on New Scientist or Sky and Telescope. This is for people interested in a presentation that not a professional presentation of this kind of results. There are a lot of resources on the web, presentations of this first research with James Webb.
Well, very good. Marco, thank you for coming on the podcast. I appreciate it.
Thank you for inviting me.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.